How's everyone? Mati here. Wow. All right, so welcome to the Java Code Camp session 3. In this session, we are going to be learning more about refactoring. If you have noticed, I am at Globant's office, so this is a great time we can spend together here at Globant office, and I'm going to be working today in how to do refactoring using a technique called how do you call it? Domain-driven design. So we're going to be using domain-driven design to do a refactoring. So, so you guys can hear me fine, I assume. We have my team is confirming that everything's working fine. Sorry for that. This is a new setup that we have at Globant's office. So we have been finalizing all the details. And welcome to the Java Code Camp. We're going to be coding live. And if you haven't watched the two previous episodes, I welcome you to check them out, because we have learned a lot about refactoring, how to refactor legacy code, how to work with a code that doesn't have any tests, how we can work using solid design patterns and the solid principles. And now we are going to be working with this new code that we are going to share in the comments, and we're going to be talking about how we can use domain-driven design principles in order to refactor. So welcome to the Java Code Camp, and let's start talking about our domain-driven design. All right. We have our code here. Sorry, this is all I'm going to present now. But this is a new setup, so everything's live. All right. So we have our subject for today, domain-driven design. And domain-driven design is an approach to software development that focuses on creating a shared understanding of the problem domain within the development team and aligning with the software model with that domain. So what we try to do when we're doing domain-driven design is we're trying to model our software around the problem that we're trying to solve. So if we want to solve let's say a banking problem, then we'll start hearing a lot about accounts and payments and so on and so on. Or if we are talking about a hotel booking application, then we will hear a lot about hosts and hotels and reviews, and also payments and many reservations, bookings, and so on. So depending on the domain that we are working, we want to model our software so that it can represent that domain. To do that, we're going to be using a set of techniques. And this set of techniques are here and are the ubiquitous language. That means we try to use the domain language in everything we do. So if we do something with, as I said before, with banking, then we'll be hearing a lot about accounts and customers and payments and debits and credits and so on. And we want our software to represent that, and we want to use that language in our model. We don't want to use a different language than the one that our domain uses, or our, let's say, not our domain or our problem, right? The problem that we're trying to solve. We're trying to solve a banking problem, so we're going to be using that kind of language. And we want to use the same language across the board. We don't want the business people, for example, using one language and the developers using a different language. We want everyone to be aligned and use the same language so that we can all share the same understanding. Also, we'll define contexts. So we'll define limits in our applications that will help us understand where some domain enters, and then we have subdomains. For example, in the case of a hotel booking application, you will have the domain of the, let's say, the customer reviews. Then we have another subdomain, which would be the dealing with the hosts. Another subdomain will be the communications, for example, how do we handle communications between different clients, and so on and so on. So we'll want to define those domains, those subdomains in our problem, and then part of defining each subdomain is defining which entities and value objects are there. And we're not going to be using all of our domains here. Sorry, not all of the principles of domain-driven design, because that would take a long time. But we want to introduce it in the context of refactoring, right? We want to know how we can use these principles to refactor an application and make it more usable, more maintainable, more easy to use by different kinds of users, not only technical users, but also business users, product users. How we can share this same understanding with everyone who is involved in the application. In order to do that, we are going to be also, for example, in this tutorial, we're going to be focusing a lot in the ubiquitous language and the bounding context a bit, then the entities and value objects as well, repositories and services, and those are the things that we're going to be talking the most about, because we're going to refactor an application that is quite old and that it has some code that needs to be improved, and we want to do this using this kind of design. So here's our tutorial, and some of you might recognize this tutorial from our functional programming series. In this case, we're going to use a different technique for refactoring, and we're going to be focusing a lot on these domain-driven design concepts. So it's a different exercise, it's a different kind of approach for the code. So it's a good thing that we know this problem so that we can introduce different concepts. And you can then have an array of many tools to play with, not just functional programming, but you can also use domain-driven design, solid principles, new tools for doing tests, everything you can use for actually doing your applications. So this is going to be our tutorial. I'm going to explain it very quickly for those of you who are joining us for the first time, and for those of you who haven't done the last Java Code Camp. And if you haven't done it, you can look at it. It's in YouTube. It's available for everybody. So I really encourage you to look at that as well. But let me introduce this. So we have a delivery company. So it's a company that does delivery of packages. And we have many packages that this company has to deliver. And the packages have a particular weight and a volume, and they also have a district where they have to go. And you have multiple packages that we're going to assign, and then we are going to be sending these packages to different, we're going to assign these packages to different trucks that are going to deliver the packages. And these trucks have also a particular weight, that the maximum weight they can carry, and a maximum volume they can carry, and also they have different districts they visit. So we can only send packages to truck 1 if they visit district 1 and 2, and truck 2 is district 3. So those are the rules, and we are going to be taking a look now at the code. This code can be downloaded by you guys from the GitHub that we have already shared in the comments. So if you couldn't get the link, you can ask there, and the Globant team will share again in the comment section. So let's take a look at the code. And we'll start with our delivery allocation service. Okay, so this is the service that we're going to be modifying. So this service takes a string, which I'm saying hi to people there. This service takes a string, and this string represents the packages that we're going to be sending. So in here, we can already see things going on. Like, for example, first things we're doing is we are parsing this string into multiple lines. You see, this line here, it does a split, and it takes it splits the string with the line separator. So we have multiple lines, and then for each line, we transform each line into a string, into a package, right? So we have the first column is the ID, the second column is the weight, and then the third column is the volume, and finally we have the district. So we have all this in the delivery package. We put all the delivery packages in a list, and then we check a few things, like the list shouldn't be empty. If the list is empty, then we'll stop the program. There's an exception. And here we have also if the truck list is empty. So the truck list we got from the repository. And in here, we are already touching upon one of the design principles of the domain-driven design. We have a truck repository. So this is a good thing. This is already there, so we don't have to do anything about it. But we'll talk about this because we want to understand what the repository pattern is all about. All right, so if the truck list is empty, we'll stop the running of the program as well. And then we have the packages, allocations. So basically we're creating a new object called the package allocation, saying, okay, for each package you will allocate it, and you will so you go through each package, and then you look at the list of trucks, and you see, for example, the truck. So the package has some validation. The weight of the package has to be between these two numbers, 0 and 25. We don't really know what they are. Like, is it 0 or 25 what? 0 or 25 kilos, grams? It could be anything, right? So, and then the same happens with the volume. We don't really know what this 100 or 25 mean, or what is the unit. So how can we be sure what we're talking about here? And then there are errors. Then we have this part here, which checks if we here. In here we check if we have the trucks here, and it gets the district number, and then it checks if the district number matches with any of the district numbers of the truck. Really, really weird method here. Like, this is not easy to understand by anyone, not just a technical person. Like, not just a business person, but a technical person cannot understand this. So how do we do this? What do we do with all this? And then the same here, for example, we have the volume. So this is easier. It's trying to check that we're not exceeding the maximum volume. But again, volumes are just integers. So how do we know it's the right, is it in the right unit? Is it kilos? Is it pounds? Is it whatever? Like, it could be anything, right? And the same with volume. Like, it could be liters, it could be cubic centimeters, it could be whatever. So we don't really know, and this is really hard to work around. Okay, so we also have a package allocation here. So it's creating a package allocation. This is fine. Like, this I like, because it's saying, okay, allocate this package, and it's creating an allocation. So then finally we have a check whether or not the allocation was created for this package. And if it wasn't, it throws an exception. So I think the logic is quite simple. Let's see if we can write a test for this, at least 1 or 2 tests, and we'll try to make it as fast as we can. So I'm going to use a shortcut, which you should learn, which is Option Enter. If you learn one shortcut in IntelliJ, you have to learn this one. It's Option Enter if you're using a Mac, or Alt Enter if you're using Windows. And if the guys on the chat in the Globant team, they can put it there as well. So it's Option Enter for Mac, and it's Alt Enter for Windows. If you had to learn one shortcut in IntelliJ, please learn this one, because this is an intelligent context shortcut. Anything, it can suggest anything. So in this case, it suggests that I can create a subclass, I can create a test, I can create many things. So I'm going to use it to create a test. Fine, so we're going to use JUnit file as we always do, and we can also tell create a test for this. It will create a stub of the test for our method. Okay, so now we have a test. We don't have this dependency, so we can add the dependency. And again, how do I add the dependency? I could go to the Maven file and do a lot of things, but I am using IntelliJ and I am using shortcuts. So I'm going to do Option Enter, and it already offers me the option to add JUnit 5. So I'm going to do that. Always try to use Option Enter. And then you can, if it doesn't work, it doesn't work, it's fine. But at least you can get a suggestion, and maybe it's the right one. So now we update the Maven dependencies there, and we can start writing our test. Let's just make this a qualified import. Again, Option Enter. Remember, Option Enter, Alt Enter. Okay, I will stop saying it because it gets really repetitive. All right. So let's write the test. We'll create a new delivery allocation service, and it takes a truck repository. All right. So we don't have a truck repository. We could either create a mock implementation or use a mock library. I'm going to create a mock implementation. Allow me to do this because, and I'll tell you why. We'll use a little bit of functional programming here. We can implement it as a lambda because we have only one method in that interface. So let me look at it. If we look at this interface, it has only one method, find all. That's it. So we can actually implement this as a lambda. So if you look at this, IntelliJ would even suggest it. I can do control space and it will throw there the lambda. So it takes no parameter because it's find all, and it returns it has to return a list of repositories, of trucks, sorry. So I'm going to create list of, and we have the delivery allocation service, and in here the list of trucks, and the list of trucks we could say new truck, and the truck ID 1, sorry, it has to be a string, so we'll put it like this. Then we will put the max weight, could be, let's say 1000, then max volume, let's say 2000, and then current weight 0 because it's empty, current weight 0, and list of district, we will say list of district, and we could use district 1 for the first truck, and we could use second truck. Let's just put it different volume there, different weight, and we put it district 2, and we could use district 3 as well. Right? So we have our list of trucks, which is really good there, and we are going to say delivery allocate trucks. Now we say we have to send the packages in. So packages is a string, so we're going to create a string here, and we have to say for example 1, we'll say 50, no, let's just say 10 and 20 and district 1, and then another row could be 2, 15, or let's just use one package just to make it more simple. Let's put this into a variable and say packages. Okay, all good. And I'm looking at the chat in here just to see if there are any questions. So there are no questions. We'll move on. And all right, so now what we have to do is we'll put the result of these package allocations, and we can do an assert. And actually, I'm going to put this list of trucks into a variable in the containing block. So trucks, so that I can also check the capacity of the trucks that was changed. Maybe I can check that. So we have package allocation, but I think we have the truck also in the package allocation. So we'll see. Get, and it should be only one. So we could assert actually the size just in case. There should be only one package allocation. Size. So we have that. Then we have package allocations, get, 0, and then we'll do delivery package, sorry, truck. Let's just check truck, and inside the truck we'll check get current weight, for example. I think the first one is the weight. So the first truck goes to district 1, so this one should have a current weight of 10 now, right? Because we added 10. So let's check this. This should be 10. And then we'll check the volume and get current volume. That should be 20. And that's fine. And also, all right, we can check also the ID of the truck. So the ID of the truck should be 1. So truck get ID. Fine. So let's run this test now. Let's see. Test is running. It works. Brilliant. Now let's move on very quickly here. Let's create one test for some edge cases. So we'll move on really fast. So when packages is empty, right? So let's see what happens, because honestly, I don't know what will happen here. Let's try this. Let's see what happens. So we should get an exception here, right? Based on the logic. So we'll use assert throws. Assert throws, we'll need to put the exception that we are expecting, and which is the code inside the lambda, the code that is going to throw the exception. So we put the execution, and that's it. We don't really need to check anything else. So we'll see. Let's test this. It works. Let's go with another edge case that we had. Actually, let's check. We can assign the exception that we were expecting here, and we can check, for example, assert true, and exception get message contains and something. For example, what would it contain? Oops. What could this contain? It will contain the right. The exception should be this, I guess. So let's see. Right. Let's run it again. While this runs, you let me know if there are any questions so far. All right, so there's an error here. Let's just use a different way to compare this, just because so equals, because I'm honestly checking for equals anyway. So let's just put this outside here. So there's a difference. So we'll need to check why this difference. Index out of bound. Wow. This is unexpected. This program doesn't even check for index out of bounds. Let's see where was the error. Where it was. This probably here the index. So or it could be here. Right. So this is really bad, really bad. We'll need to fix this code to make it work, because yeah, this code doesn't even handle that. So we'll refactor it so that it can handle that scenario as well. Let's just remove. Let's just keep the assertion here, but we will actually change this scenario. We'll put this assertion like that for now, because we'll need to change that scenario. And let's create. But we know there's a problem with the empty packages list. So that's a scenario that we need to take a look at. And then what else do we have? Maybe the list of trucks is empty. So we could say collections empty list. This allocated trucks when trucks is empty. And in this case, we're returning this. We need to clarify here that it's a truck list. And so in this case, we should also get an exception. So we'll put this here. And we'll remove this line here, and we're getting a runtime exception when we call. So let's see what happens. And okay, so it works. And now the last test that we're going to create is what happens if we send two packages, let's say. So we'll put one package there, and this second package could be 2, 15, 15, and district 3, right? 1, 2 packages. And now this assertion should be the same. Size should be 2 in this case, because we had 2 packages. And then, sorry, it should be, yeah, district 3 we have. So here we should add other assertions. And in this case, we're going to say get 1, so the second package allocated, and it should be the truck will have 15, 15, and the ID of the truck will be 2. So I think this should work. Let's run it. And it works. So now we have a lot of tests, so we can refactor safely. All right? In an ideal scenario, we would do more tests, but since we're doing a demo here, we don't want to do all those tests. But in an ideal scenario, I would even go even further than that and do more tests. All right. Any questions so far? Let me check. I think we're good. No questions. All right. So we'll take a look at the code and see things that we can see are weird. For example, we can notice that these allocate trucks is receiving the string. So this is a service, right? And in domain-driven languages, what we want is our services to handle business logic. But what do you think? Parsing the string into packages, do you think that is business logic? Because it doesn't look business to me. I mean, a business person doesn't really care how we parse the CSV, right? The comma separated values. It's not business related. So why is it in the service? And this goes with the principle of using services for handling business logic. So remember one of the principles of domain-driven design is using services. And services handle business logic. So if we want to talk about business logic, this is not business. This is not a domain specific thing. This could be another domain, or it will be part of our application. Because remember, I mean, our applications have to have some sort of, inevitably, applications will have things that are not business related, because in the end, this is a representation of the business. This is not the actual business. And this representation needs to have some sort of support. So a file, in this case, or a string, is the support for this representation. But we want to abstract these things so that they're in a different place. So we don't really want this parsing in here. But first things first, we would need to maybe put this into a different place, just to make it more easy to understand. So just for the sake of this exercise, we're going to say parse packages file. Fine. So that is an extract method that I did. Remember, extract method is option, command, and M for method. So now we have a file parsed, and we want to we also see here this method already extracted. So if we run the tests, everything should run. Okay. Let's just I didn't run the whole suite, so let me just run all the tests. If I run everything, everything should run, and everything actually runs. So we're good. So ideally, we would move this into a different place. So let's just go ahead and do that. Let's just create here a new class, and we will call this class, let's say, file. Let's just say, let's name it. I'm a bit hesitant here, but we could name this a packages controller, because this is going to be handling the communication between the presentation layer and the service layer. So we could call it packages controller. So and also let's say that it's a file packages controller. And so we created this class, and let's just put it in the controllers package. There we go. And we'll move that method here. So now I have the packages controller. Oops. And let's just say that the packages controller will, or actually, instead of packages controller, let's just name it packages file, packages file parser, because this is actually parsing it, and that's all. So let's just name it like that. And if we go here, we could put it packages file parser dot parse, and I had to make it public. So this is a static method. We can use it already like that. And if I run everything again, everything will run. So my refactors are very safe. Well done. Okay, so what are we going to do now? We still don't like this here because it's messing with our business logic. So we are going to be parsing this in a different place, and that could be where could this be? Let's just I know. Let's make this receive a list of packages. Delivery package. So now we have this list here, and we can get rid of this. But in our tests, we have 4 tests that are sending the file. So we'll change those tests. We'll do this. So we'll do a new, not new, sorry. We'll do packages file parser, parse file, and we'll have packages. So we'll put this line everywhere. We'll put this here, and we'll put it here. Sorry, we'll have to put it let's just put this here like that, and let's put this here, and we'll have to add this line in here at the bottom as well, like that. So now we're parsing outside of the service, and we're sending it to the service then. And finally, we have another one here. And I think we will face some issues with this scenario, because this scenario is going to fail here now in the parsing. I'll show you. Let's run the test. All right, good. So what happened? Why did this fail? Because it failed because the exception is being thrown now in the parsing. So this is actually a good thing, because our program was having an error that is unrelated with business logic, and it was happening inside the service. So if we have an error that is unrelated with the business logic, ideally we would want that error to come up when we are not dealing with business logic and we're dealing with parsing, for example. This is not business logic, this is parsing. So since we did that, now we can understand that this service actually has improved in quality. Now this service will not throw an exception that it's not a business one. All right, so to fix this, we are going to we should check why this is happening, but let's see. So we have split here, and it's probably failing. We can actually debug it and see why it's going on, what's going on. It doesn't hurt to debug every now and then. So this is okay, and if we go next, so you see package lines has one line, right? So it has one line. So that's the error. So when it's trying to parse the line, so you see this is not handling the case in which the line is not valid. So if it has one line but the line is not actually valid, then it throws an exception, because this line doesn't have any. So this would say that it won't have any columns, you'll see. So columns is also empty. It's an empty string. So we'll have to do a check here, something like if, let's say, columns is less than, this is a very rudimentary validation, but it's something at least, less than columns dot length is less than, do we have 4? So it has to have 4. So we have, if it is less than 4, throw new runtime exception, the file is not valid. Something like that. So now we can go in here, in our test, and remove this part in here, and we can add assert throws in here. Okay. And now if we run everything, let's just run everything, and now everything is working. You see, we even fixed an issue there, a bug that we had in our code. Now we don't have that issue. So good. It's good that we're doing this refactoring, you see? And we could even make this even prettier. We could say, let's say, validate line. Okay? And this will still work. But we'll see, we'll work in our main class, which is the service. Any questions? No questions? Wow, that's great. Everything must be very clear then. All right. All right, so we've talked about the repositories. And repositories are things that help us access the data. And they are also a pattern that we have in domain-driven design. And the good thing about repositories is that the basically interfaces, right? And we could have multiple implementations. So I just did an implementation which is a Lambda, and that is really easy to do. But I could have another implementation that goes to a MySQL database, for example, or Postgres, or MongoDB, and that is really useful. So the idea behind this pattern is that it doesn't matter where we save the data, we know that we can access it through the interface of the repositories. And that is also one of the principles of domain-driven design. Okay. Now we're going to talk about two other principles. The principle of entities and value objects. Entities are things that we will persist state on them, right? For example, the trucks that we have in our repository, those are entities because they have a state. They have the current amount of weight they have in them. Because they have a state, we store that state somewhere in a repository, and this state tell us what we are, what is the status of the entity. So entities are by definition stateful. It means they can be modified as well, right? So I can change the data. I can change the status of a truck. I can change the districts that a truck sends packages to. I can change the weight that the truck is currently assigned. So all these changes, and that's because the trucks is one of our entities, one of the entities that we have in our model. Another entity that we have in our model is the delivery packages. And a good indication that we're dealing or okay with our entities, with our domain-driven design, is that now we don't have a string here. We're not receiving a string. We're receiving a delivery package. So we have something that actually represents our business, because we were getting a string. A string is not something that represents our business. So when you're dealing with domain-driven design, you want to be very, very specific, and you want to deal with entities, or the other thing that we want to deal with is value objects. And value objects are the opposite of entities. So these are things that are immutable. They cannot change, and they help us model our entities, for example. So what could be an example of a value object in our example of trucks and packages and all that? Remember the weight? So weight is being represented with an integer, right? But can weight be negative? It cannot. Can volume be negative? It can't. So why are we using integers to represent it? And also, what is a unit? We don't know, because we could have the weight, as I said before, it could be grams, it could be kilograms, it could be tons. I mean, it could be anything. The same with volume. It could be different units. So how do we handle that? Another example that you might be very, very used to is the dates. We could represent dates with a string, for example, right? We could even represent dates with an integer. So for example, we could take the base date to be a random year, and then have adding 1 for each day that has passed since that date, and we can then calculate the actual date. But if we represent the dates in our system, in our model like that, that will make it really hard to understand which date we are actually talking about. That's why we have in Java, for example, we have the object called local date, which help us represent a date in multiple formats. And when we see that object, it has a lot of methods, like it will say format, and you can format it in many formats, or you can say, is this date between this and this, or it has a now, for example, that will return the date of today. And this is really, really useful. And in our case, we do need to validate this, because, for example, in our file, in our file here, we're sending numbers, but we could be sending anything really, and we could be even sending negative numbers like this. There's nothing stopping us from doing that. And here's where domain-driven design gets really specific, because this will help us model our problem in a very effective way. Because these are things that we don't really think about very often, but we have to, and these exercises help us. So we're going to be modeling our value objects for volume and for weight, because we have weight validations here, but we don't really know the units. So let's start modeling our value objects. So a good way to create value objects in Java, so in the latest versions of Java, we can use records, right? Because the records are immutable. So let's create a weight record. all right? And we could say it's an integer and value. And the other thing that we would need is something to represent the unit. So we could, for example, create an enum. We could say unit. So enum here, unit, and we will have here, for example, we could say kilograms. So let's say we support only 2. We could say kilograms, and that would be it will have a multiplier. So it's 1,000, and then we'll have grams, and that would be 1. Okay, and then we'll have to create a constructor for this unit multiplier, and we will assign this to a field. And you see how I do everything with Option Enter, right? Create a field for parameter. You see, you will love Option Enter. Just give it a shot. All right. So we have a unit now for our weight, and we will have a unit here. Unit. Okay. So we could say now we have to use this weight in the different objects that we have. So we'll start with our package. Okay. So the package will have a value object instead of an integer. Okay. And we will go in our service here. Sorry, first in our parser. Where is our parser? Here. And here we have our parser. So we now need to transform this into a weight. And we don't want to change the format of the file, because this could be a file that has been going on for years. So unfortunately, we won't be able to change that. If we can, then we could suggest it, but since we can't, we can assume, let's say, that we are talking about grams. So we could say that this is a new weight. Sorry. Let's just say new weight. Let's I need to make this public, I guess, right? Yeah, because I need this one, I need to make it static or public. Yeah, public. So now you see we have unit, weight, unit, gram. Very nice to read. And then we create a new weight object. And then we can use this weight object in our service here. And for now, we'll just say value. So we'll compare value, which is still an integer, and everything should work, right? Oh, in here as well. Any questions? Oh. All right. So, well, actually, this will remove it for now, this method, because we actually could add it later. We have a few methods here that we don't really want, and this one will just use value. And where else? This method as well, we'll remove it. This one as well, and this one as well. So we have a lot of helpers methods that we were using that were already there, but we'll re-implement them. But okay, so we have the way there and the allocation service. Oops, I deleted one of the methods in truck. Let's just this one. Value, update current load, we don't have to delete. We have to delete all the other ones. Helpers, we don't need them at the moment, because we wanted to implement them. So now we can run the tests and everything keeps running. So our value object is starting to prove some use. And now, what else do we have? Right, so our value object here could also validate. So instead of creating it like this, we could create something like a static method, which would be an initializer. And this initializer would be we'll return a weight, and it would say of grams, for example, right? And we can do int value, and it has to be public as well, sorry, public static, and it will return a new weight of, and it will say value and grams. Okay, but before doing that, we will say if value is lower than 0, because we cannot accept negatives, throw new let's just say illegal argument exception, and it would be value of weight can't be negative, right? So now we can use that in our delivery package parser. Instead of using this thing, we can do, whoops, sorry, instead of using the new, we will use weight of grams. And we will remove this because we don't really need it. This is the volume, sorry. Why? So in here, we would say weight of grams. Okay? And I'm forgetting a parenthesis, and we're good. So now we have validation, and that's great. All right, so now we can make sure that our weight is a proper value, and then we can also change the weight in truck. So if I go to truck, I can change max weight to be a weight, and I can change current weight to be a weight. Okay. So and this would be also a weight, and this would be also weight. So now I would say I don't have this operation now because we had to add weights. So I can actually create a new method in weight called add, right? And this will create a new method in weight, and this will return new weight, and it will say value and weight, value, and let's call this one other. So this would be this value plus other dot value, and the unit would be what would be the unit? Other. We want it in the receiver unit, so we would say this unit. Okay, that's good. So we could actually see that this could lead to an error because we would need to transform the unit to something that it's actually useful. So we don't know if they are in the same unit. So what we should do is, for example, put everything in grams or everything in kilograms. So we could say, for example, this unit. So if, or let's just use these, this unit equals grams, then use this dot value. Otherwise, this dot value, or we could say this 2 grams, for example, and we create a method here. And this would assign to a value. So we could say value return. So this value slash this dot unit dot multiplier. So if this is grams, if this is kilograms, it will divide. It will. If this is kilograms, then if it is 1 kilogram, we need to multiply, right? And if it is only grams, then it will be fine because it's only 1. What? Okay, good. This, sorry, this should be weight. And let's just use int. That's fine. Fine. And the same we'll do with other value. So this would be other unit is grams, then use the other value, otherwise do other to grams. And finally, we'll add these values. So value and other dot value, and unit should be grams because we put everything in grams. Okay, so you see, then we can use this also to compare things. So let's just put this in a different method, and let's just say value in grams, and it will replace it with everything. So you see, so now we have both values in grams, and then we can create a new value, a new weight. So now we have to change again our objects, right? So we'll have to transform everything in truck. This return weight. So actually, let's delete all the getters and setters, and let's just create them again. Just that we don't have any issues with them. Let's create all the getters and setters. So to create that, we'll do option, sorry. What was it? Control S? No, wow. I've lost my shortcut superpower. This is generate. Oh, option. Command N. Getter and setter. We'll select everything, and there we go. Command N there. And now we have this, so we can use, instead of this, we can use our method add for this. And here as well, add. And there we go. Oh no, sorry, not for volumes. We only have for weight. So weight, we add weights. There we go. And what else? In our service, we need to do, we can do the add as well. And in here, and we can create a method for this as well to compare. But for now, we'll just leave it like that. Okay, let's run everything. I think the test will need to fix because now they're expecting weights. So new weight. So we'll put here, and we'll say instead of new weight, we'll say of grams. And in here the same. We'll do of grams. And we'll have to do it again here. And in here. And where else? So in here we'll have some issues. Let's just run it again to get all the errors. Yeah, here. Of grams. We can actually do it like this, of grams. And we also have it here. And in here. Right. And we'll still have some errors in the assertions because now we're comparing different things. So in here, these assertions we just need to do. We could do of grams 10, and in here as well we'll do of grams 15. And in here we are doing it current weight. Yeah, I think we could. I might have missed a few, but let's just check. Yeah, I missed this one. But the cool thing about all this is that now I can change. So for example, what would happen if instead of this I would do a new method here, and I could say of kilograms. Okay? And I could say kilograms. So now I have a method to create, instead of grams, I could do kilograms. So let's just say of kilograms. Let's just keep it like this. So now it can take only 1 kilogram. So really little truck. But let's see. And I don't know if there are any questions so far. But let's try this now. All right, so we have an error. Unit kilograms. So we couldn't allocate. So there's definitely something wrong that we did. Max weight is 1 kilogram, right? So if we have 1 kilogram, sorry, I think we messed up in some place in the weight. If unit is grams, then give me the value. Otherwise, turn it into grams. So grams, the value plus the multiplier times the multiplier. What could be going on? This is a problem where I'm going really fast, and I should have tested actually this method, for example. But because we're doing this demo, so let's see. I'm going to have a breakpoint in here, and let's just run this in debug mode. And here we are in the wrong class, and here now. So we have two trucks. The first truck has a max weight of 1 kilogram. So let's see. If I run this part here, what would happen? I'm going to run this part, the adding of the values. I'm going to evaluate the expression, and the result is 10. All right, so I'm adding the truck weight and the package weight. So if I add the two of them, and I'm going to express this, evaluate, This is returning a new weight with value 10. And why? Let's just see what's going on here. And let's evaluate this thing again. Why is it happening? The value here. Let's just run this. Unable to allocate, no truck available. Right, so let's run this. Oops. Let's run it in debug mode. All right, so we have the two weights here. Other is 10. Value is 0. This is something definitely odd. Value is 0 of kilograms. Why? Let's just run it one more time like that. What is value in this case is 1. So let's see. We can create the value. And then here value is 0. I don't understand why this is happening. But I probably messed up somewhere. So when we create the truck, we send the weights. Let's see what we're sending here. This is fine. We don't need this. So we have the truck we're creating. Current weight is 0. Right. Oh, that's fine then. Current weight is 0. Oh, I guess I know. All right, so if we go to the service now, very quickly. So max weight, we're comparing values. This is the problem, guys. Let's see. You know, this is what's going on. Let's just say is lower than, let's just say like that. And let's create this method. Lower or equal than. Create method, max weight. Let's just call it weight other. And let's put all the values to grams. So like we did before in here. And we could say return value other value. So now we're talking. Let's see now. Yes, now it works. So yeah, that was the problem. We were comparing values here. So you see, now we have this, and this we could even put in a different method. And we could, because this is a long method here, we can put it inside truck, to be honest. So we have the truck class, and we could say, for example, Boolean public boolean exceeds weight, exceeds max weight. And we could say weight or package. Delivery package, a package. And we could move this logic that was in the service into the truck class. So truck exceeds max weight, a package, weight. No, sorry, a package. It receives the package. So now we're talking, and this would be this, and this would be this. So current weight plus the package weight should be lower than or equal than our max weight. So you see how this goes really well with the domain language. Because now we have a method that it's really easy to read. So current weight, and we could even remove this. So we could say current like that. Add a package weight is lower than this the max weight. Really, really easy to understand. This is something that anyone can read. Like someone who is not technical can read this and say, yeah, I understand this. So let's see why this is not compiling. All right, missed have an extra thing there. And we're good. So now let's run everything. I'm going to run all the tests. Missed in return statement. I'm going to run all the tests in our service test. Brilliant. Everything is working. So we could go along and do a lot of refactoring in here. For example, we could put all this into the truck. We could say, for example, we could do the same with volume and say, for example, instead of this, we would say truck exceeds max volume, and it also receives the package, and we would put this logic inside the truck, and we can start getting rid of these parentheses because they don't make, they are not of much use now. We create this method here, and we return this and this, right? And we can do the value object with volume as well. So these are the cool things that we can do with domain-driven design. So we're now getting everything validated. Let's just run everything. And I will let you do the value object, but with the volume. So you can tell me how that works for you. Okay? And let's see, the other thing, the last thing that we'll put also in our truck, in our location service, we also have this method here, which is very long, and it only says that the truck delivers to the district of the package. So we would say we could say that here. We could say truck delivers to district a package. So this is also a question. And in this case, we'll say this. You see? And we're using the domain language to model everything in here. Any match? So now we have this method in here. And this could also be even more refactored. So now we'll put this right in our service. Now we can get rid of all these parentheses and we can even reduce it even more, because we can change this to truck can deliver package, a package, right? And now we say return all this. So wherever it says truck, we say this. So this is, you can read the business logic here. How can I know if a truck can deliver? It can either delivers to the district and also doesn't exceed. We should call it doesn't exceed, not exceed, sorry. Doesn't exceed and doesn't exceed max weight. So you can read really the rules of the business with all this. And this is because we're using domain-driven design. Now we can test our refactoring, and it all works. So you see how our code is changing a lot. And the last thing that I would like to do is I would like to create so in domain-driven design, this section here, I mean, why can't we introduce a new domain? So this is something that we would speak with the business people or with the product people. Why don't we, instead of throwing an exception here, why don't we create the concept of a empty allocation or a non-allocation? So instead of having this error here, let's remove it. So if the allocation is null, just say what would I say? It would say package allocation not allocated and a package. So in our result, we will get this package and it will say just this package has not been allocated. But I can allocate, at least I can allocate all the others. If I had the exception there, then I couldn't allocate anything. But with this scenario, I can allocate all the other packages and there's one that I won't be allocating. And that's fine. So I'll change the test now where I don't think I need to change any tests for this, but let's just try it. Yeah, I didn't have it change any test for this. But you see now, oh, sorry. Package allocation. So now I needed to assign that. You see now I am allocating. Now I can process everything. So if I have a let's just put a simple case where the package, there's one package, let's say like that, and let's say there is there's only one truck, but this truck only takes things to district 4, right? So because it takes things to district 4, what's going on here? I think I need to delete this, right? List of trucks. Have a new truck. And let's just put here, no allocation. In our old case, I would expect to have an error here. But in the new case, what I'll have is an allocation that is, so I would say package allocation get, and truck would be null in this allocation, okay? So it would be assert null. And the other thing that I can check, because the package allocation will have, if you see the class not allocated, it creates something with delivery status not allocated. So I'll check the delivery status in here. This should be get 0, and it will be get 0 delivery allocation status, and the value would be not allocated. So now I'll run all the tests again with the new scenario, and it's not working. Index out of bound exception. Where? Have one truck, right? It's going to district 4, delivery, allocate trucks. If it can deliver, then break. If package allocation is null, then package allocation not allocated, and we added what is going on here? Oh, sorry, that's the problem. Now let's run this again. And everything passes. Wow. So, I mean, there's a lot of refactoring still to be done in here. We can remove this validation and put it in our file parser maybe. But you can see how this logic is getting better and better every time. For example, if the list of trucks is empty, we don't really care about this because we now have empty allocations. So we can remove this validation, and we should be getting empty allocations in the case that there wasn't. So in the case of, for example, in this case where the list of truck is empty, we could simply say, and I'll do it quickly with streams, but we'll say delivery packages stream map and a package, and this package is going to be package allocation not allocated, right? And this would be a package, and I can even replace this with method reference to list and I can basically return this. So if it is empty, just return it. Return an empty list. So we had a case in our test for an empty list of trucks, right? And we had an exception in this case. So now we will remove the exception. We hit, and we'll basically have a check for an empty allocation like we did here. So now in our empty truck, we'll choose have empty allocations. So with a new business concept that we agree with the business people, with the product people, we can introduce new business logic that will help us prevent errors or model the errors as part of the business. So the fact that there is something not allocated is part of the business. That's why we do it. All right. I think we can take a look at what we have as a result, but you can keep improving this, adding these little domain things. So I want you to keep using this domain-driven design to keep improving this code. But you can see how now this code is much nicer than what we had before. We can extract these validations just to make it a bit more nice. But for example, validate volume and validate weight. And then this could be somewhere, we can move them somewhere else. But this code looks way nicer than it looked before. Don't you agree? And this is all because we were using good design principles, domain-driven design. So that was basically everything that I had for today, guys. I thank you for everyone that has watched this to the end. It was lovely to be here with you, and I'll be waiting for all of you in our final session of the Java Code Camp next Tuesday, and it's going to be a very exciting episode. So I'll see you in the next episode, and bye.